In a world that walks the line, there's a rare few who think outside the box together for the crew. To break the equations, not bound to any rule. Exposing to the world the universe's own view. It takes the talent of the craftsman, it takes the mind of the fool, to make the vision realize energy and matter in a duel. To a break, to a duel. The old man, bills was running through his head. Cheryl probably got it hiding under his bed. Penny up the ante, making power for days. Don't listen to a word that the straight dope says. Mike building batteries to power a ship. Victor comes in talking math as the water spiral dip. Sean chucking plasma bolts a mile long. Sheila on the video making tone chucking prongs. Bernie breaking matter, they said it couldn't be done. And to all the people in the chat, I know you're having fun. So it's time to spend your Saturday with the dope big old man Bills.
Hey, what's going on, guys? I'm Nathan, otherwise known as Old Man Builds. Joe, what's up, brother?
TGIF, folks. How are you?
Doing great, man. Just hanging out, getting ready to watch some Graviflyer stuff, dude. It's I know we covered it like was it 3 weeks ago, but we got some more results in lately.
Yeah, it seems to be you've been putting a lot of work into it, and I know that it's maybe been difficult for some people to see what the progress actually looks like. When we're just talking about the theory surrounding it or showing it, trying to start up with no context. But I think you were able to get some better data off of this last set.
Oh yeah. Let me just put it this way. I have a little folder, a little binder, right, that I keep, and this is probably one of the first successful tests that I had in the binder. Now, mind you, that's probably a year old, maybe a little longer. Mm-hmm. So this is just one of the written down ones. As you see, if you notice when you look at the Graviflyer, the plates are all bent, crooked. I did not put a lot of time into fixing it again. I just set it back to what the original specs were when I ran the thing the first time. So I knew this result a while back, but I was talking to Joe about it. I didn't know if this qualified as any type of anti-gravity. You know what I mean? And I was reluctant to show it because I didn't think it did. He says, go ahead and show it.
Yeah, I think it's important for people to see. And, without trying to make a claim, you could kind of see it and judge for yourself. And the interesting thing is, I think that I have a little bit of a hybrid alternative theory.
Okay.
To what maybe, Nathan was thinking. But the funny thing is that, the end result being the same, even when the mechanism's a little bit different, which I find to be, pretty unusual and interesting, worth exploring. So, yeah.
Very cool. Let's take a look, guys, at what we're looking at here. I'll just put this on here. This is basically the test, the short version of it. You could see it lifts. It slightly falls every time that it lifts. So, and then it'll peak out right there. And then right after it peaks out at that point, I think you got just a hair higher. Then it just fell just a little bit again. You know what I mean? So it's like it's readjusting its position in there. And I think that has to do with just the way the scale is itself. You know what I mean? And how the scale functions. Mm-hmm. But, either way, it's still doing the thing, man. It's still losing the weight. So you can see as I click through this, it's like down here, right past 5 going into 6. Right there. So right at 6. And then it comes all the way up to close to 4.5. Is right there. So, I called about 1.5 pounds. You could say less if you want. I won't be offended by that. But, yeah, it does what it's supposed to do. So, all right. Joe's got a video.
You want to show the video that I just made that shows, because you can see the motion there, which I think is interesting.
Let's do it so we can see it. And then, because I want to get into what I actually did to do it. You know what I mean? Because people want to know it. You know what I mean? Because they got mad at me for not putting any volume on the video. I just got tired of talking, guys. I've been saying this so much. I thought everybody knew it by now. Anyway, here you go. Tell us what to focus on, Joe.
So what I did here was I took the same video and it's running at the exact same time, left and right, and the one on the left is showing the overall um, snip, but then I zoomed in close to the Graviflyer's leg where it meets the board, where it's attached to the scale. Right? And I superimposed a line over the edge of the board there, so you could kind of have a gauge here. And you can see on the left that there's no camera motion or anything like that. So I wanted to show the context. And if you go ahead and roll it, you can see you can see the motion.
Okay, let's go ahead and play it.
Yeah, so if you're watching the line,
you can see the whole plate move. There it is, right there, right there.
You can start to see that lift, okay? Then you can see that it's on the camera motion.
It's like it's pushing back down.
It's so like I said, I have my own idea as to one of the things going on here.
Go ahead, Joe. I'm just going to play it while you do it.
Okay, so I'll say my piece then, sure. So it was ironic because there's a Russian guy in the comments that was like, "You buffoons, you succumb to trickery and the magician once again," and then he goes on to explain it, as a vibratory, type of phenomenon, right? Like well known to physics, and I don't disagree. The thing is understanding how what the mechanism of that is, and that this was before I even read his comment. That was sort of my takeaway on this. Right, you have to realize how the analog scale works. Right, it's a spring, and anytime that it's going to have a measure that's not zero, okay, that's automatically loading tension into the spring that acts as its ability to measure the weight. So by putting the Graviflyer on it, you're automatically asserting stored energy in form of a load. Now, if there's anything that you know about the response time of stored energy is that it's instant. Okay, so any time that there's less force applied against it, it's immediately going to take up and make up for that difference, right, with the stored energy through what it has, loaded into the spring. So whenever you bring something into a high degree of frequency and oscillation, okay, and it starts doing the shake, well, what is a vibration in itself? It's micro points of loss of contact, okay? And if you notice, you'll see it actually rotate around the three legs. Okay. And so there's a point in time during the sequence where the load is varying as it's lifting up. Now, as the frequency goes up, the more often this occurs. And then what allows for the creep of the scale, the creep upwards, releasing that stored tension, which then measures as a weight reduction. Now, what's interesting is that it is, in fact, a weight reduction. Okay, it's a weight reduction because the force that's being applied to the surface directly below it is not as much as often, you see? So because it's losing contact, right? If you're not in contact with the ground, then what do you weigh? Well, you don't. And that tends to be the thing. It's like, what do you weigh in a free fall? You don't, right? So it tends to be the exact same type of dynamic that's existing there. So by it having a higher frequency, and that frequency increases, is more time that there's loss of contact of each leg, which allows for the creep up. But again, Now, if you bring this to a high enough level, okay, there's a point where they're not really in contact at all. And that then lends itself back to some of the, um, the harmonic resonance techniques of levitation. Okay, that like they said about the monks and how they used to do that with different chanting and things of that nature. So it becomes very interesting. That's what I personally think, but I think that there's also a field dynamic to it as well. I think that what it's not is thrust. Okay, I think that that's important because I think a lot of people would say thrust, um, and I just don't see it that way.
No, I don't see thrust there.
I
I
agree.
I see something totally different. And well, how do I want to describe this? It doesn't work without the field on the outside of it. Okay. So if you think it's purely mechanical, that it's taking a height and then staying there, well, none of that works without the field around it. So it can't get up any higher to reduce the weight. It'll, you know what I mean? You'll hit the button and it won't do anything. The number will stay the same. It won't go. It's the fact that the field's catching it. It's holding the position of where you put it up to. Okay. So let me explain the mechanism behind what I did. And you got to kind of understand this. As soon as you rotate the bottom disc, right, you have magnets on it. You get torque. And you have torque, and then you let off the pedal of the gas, right? Or you let off the motor and put it into a stall. It still has rotational force, but it doesn't have torque in the same way that it does, right? If you change that angle that's on it and you put it at an angle, now you have a torque in one direction as soon as you restart the engine, right? So as soon as you restart the motor, boom, it has a ability to move up, right? So that's one aspect of it, but there's a second one to it, and it goes to a physics principle with a wheel and a string. Spin the wheel, you have the string, right? The string's right here, and it goes to this on the wheel, and here's the wheel spinning, okay? Now, here's the thing. There's force applied onto the string this way, and it holds it in position while this rotates here. What you need to do is take another force to that right there, that's here, and you want to pull it. At all times, you want to pull it, okay? Now, it cannot dominate the rotational force. It just doesn't work that way. If you have too much torque, it can't dominate it. So you have a two-trap system. One, the wheel spins, right? Then you let off of the torque so that it's just rotational speed. Now the secondary part pulls in. It's always pulling because you didn't turn off the piezoelectric buzzer. So it's always pulling the entire thing. So what happens is this becomes dominant versus the torque going on, and it pulls it up. And what it does, it catches inside the field itself. It's a bubble separated from the gravitational field because it's built of the gravitational field. So you have to just understand, it's just two-stage mechanism for how he made it lift. It's not overly complicated, but if you don't understand that rule of torque and how to shut it down and just deal with the rotational force while another force becomes dominant, that becomes an issue in how you see it working. Because we used to go, okay, you turn off the piezoelectric buzzer and it bumps up like a bubble. That doesn't work because it's not a continued force on it. The piezo has to stay on because it's basically working in between the plates. When you see this on a cosmonaut mirror, I believe it is, you see the individual lines, right? And here's the line for your top of your asymmetrical capacitor here. It locks right into it. So as this pulls with it. When this pulls with it. Well, it's only going to do it for a second or two as you let the torque off. That's the key. You cannot continuously do it because there's too much weight. So it has to be a real quick, forceful pull. So it goes boom, yanks it, it's able to move up. Now, it has to catch in the environment like a magnetic field. And this is where it's very, very important. And I found this, and I don't think anybody's ever understood it. So let me try to make it understandable in a different way for people. I am taking the environment and switching it, okay? Because it's like a radiation sheath zone that I need to pull into a magnetic zone because I want to take a magnet and float it in the middle of the air, but I can't do it unless I can make that change, okay? So I have to be able to play with the locality of the energy that it's in. Therefore, I must couple with it.
Yeah.
The only way to couple with it is either you build it by yourself and match it, which we can't because we don't know all the parts to everything in the entire Earth, or you simply use a system that's used to couple with things. So your Slayer Exciter Ungrounded works in that way. It tries to resonate with everything in the room, your power source, you, anything it comes in contact. This thing is powerful, man. If you've never played with my Slayer Exciter, you don't understand. It tries to grab everything in the room and then it'll hold the power and then bust it out in a big burst and set off like an EMP in your room. Okay.
Mm-hmm.
So understand that, but understand now what's going on. The center of the coil, you now have this hole. It's filled with air. It's filled with the environment. But now it's directing the energy from that coil into that wire. So it's coupling the two fields. It's coupling the energy from the actual environment along with the coil itself. Now it's trying to resonate it together. Now they're working hand in hand. Now, when it sees the environment now has the ability to take that coil and make it a magnetic field quickly and change the dynamic of what's going on. It looks to the rest of the environment just like the environment. It's like I took the environment and put a straw in it and I blew a bubble. Okay? It's exactly what the environment sees. Now, I'm able to flip it into a magnetic state because it's like T.T. Brown was trying to tell you. It's a weak force, which everybody calls gravity, turned into a strong force, which everybody calls magnetics. Okay? But being able to transfer between the two in that same field, that field is the most important field in physics. I'll tell you that right now to understand this whole problem. The lift factor, who gives a crap? That's poor propulsion. I could have farted and made it go further. It's real simple, man. Without that bubble, you don't have anything. Okay, so
yeah, you need the bubble to hold it together and hold it in. Either that, or it's just in a state of diffusion, or that state of diffusion is too loose to act against. Is what it kind of comes down to. But it's important to identify the correlations here between a couple concepts that Nathan was talking about, and first of all, spin being one of them. And it's funny how things tend to align like this, because I think Ashton Forbes just had a little bit of a dopey quote on this a day or two ago or something about, how spin is the interdimensional axis, which, interesting topic for another day and it's a little off subject. Anyway, but the spin being a major factor, what you have when you have a relationship between two spinning objects with stored momentum, right? And how they play in a relationship with one another. It becomes easier to kind of imagine, right? If, let's say you're running along a train track, right? And you're traveling at a certain rate beside this train track. And you have two scenarios. One scenario where the train is coming toward you at whatever speed it's traveling. The other scenario where it's traveling from behind you. Now, this isn't spin. This is just simply axis, right? So there's a difference in the felt response based on your direction of inertia and that passing train. You see, when it's coming at you, it blows you away, or that's the felt response, is to be pushed away. When it comes from behind you and it's traveling the same direction, there's a pulling force that you feel. Now you add rotation to this, okay, because you have the direction parallel, right? And they share the same type of relationship when it's counter rotating. When it's counter rotating, there's cause of torque between them. So you have, even if there's only stored momentum and no torque drive force, there's still a torsion event that occurs that is then mechanism of a torque event of a repulsive force between the two, just based on the spin alone. Now, when you bring the higher energy densities and field dynamics into the equation, and then you flip it, like you said, you're going to stall one, okay, and then you're going to make one dominant over the other. And when you stall one, if you ever notice what happens in that scenario, is visually it appears to then spin opposite of how it was. So if you visually can see it spinning clockwise and then you stall it, it appears to then move backwards, even though it's still moving in the same direction, just because of the speed differential and the fact that there's stored momentum on the other side. So, you bring the energy, the density levels and the field dynamics into this with the bubble, and you could start to understand how there's a lot of forces that are all bouncing off of each other. And that is sort of the bounce that you get to see in this. And if it wasn't for the bubble, what you would see, okay, if you now take this in comparison to what I said earlier about what I believe the mechanism of the observation is, the stored energy creep of the analog scale, in the spring, okay, the stored tension. All right. What it would do if there was no bubble, okay, is as the frequency would increase, there would be a new center of gravity that would find itself on the plate, which would then have a new average, okay, weight distribution based on the amount of time, it's off of the plate, okay? So you'd get a very small reduction, very small, okay? But once the field dynamics are in play and the bubble's in play, what it allows that to do is creep up, but then hold, and creep up, and then hold, and then creep up, and then hold, rather than just find this new average as the frequency changes. Because if you're just looking at the new average when the frequency changes, like the Russian guy that was like naysaying in the comments was saying, yeah, you'd end up with a lower number, except it would be so marginally small in comparison to the frequency, okay, that it would not be a substantial portion of the overall weight applied.
Well, hold on. You can't change the frequency in it. It's because it's locked.
Well, there's a rotation rate, which
No,
is the frequency.
Right. That's the core frequency. All of the field frequencies beyond the manual part, they're locked.
Right, but that's not that's the field geometries, right? And those are building up separate of what I'm talking about.
Okay, I just want to make sure.
You chose a system that moves mechanically, and that mechanical movement carries with it its own frequencies that are, in this case, a visual impact on the measurement. You know what I mean? It's an actual impact on the measurement too. But again, it would only find a small reduction based on a new average of a varying center of gravity. Okay, as opposed to having it ever increasing. That ever increasing can only happen because of the second part, okay, which is the bubble and the field geometry. That's what allows for it to lift. Like,
oh yeah, because it'll laugh at you all day if you don't put that bubble on there.
Right.
You'd be wasting your time.
Once that average is achieved, that would be your loss. Okay, because then it would do this, right? It would just do this. It'd be sitting on the plate and it'd be doing this, and then where the pin would be here, and then the pin would be there, a node and an anti-node, and dead in the middle of that would be your average, and that would be your new average. But overall, that average would be less than what it was if it was not in motion. Okay, what this allows it to do is it allows it to creep up and then not creep back down entirely, creep up and not creep back down entirely. That way you get incremental increases, okay, as everything falls into place.
So I just want to explain something real quick, Joe, and I get into the mechanical side you're in. The upper fields, the high voltage and the Tesla coil, those two fields that are going on in there are locked because of the piezoelectric discs. They're locked. Once you get that thing to scream like a banshee, okay, and you get that thing correctly set to the right depth by the amount of power put into it, it screams like a banshee. Why does it do that? It does it because the actual lines are crossing in there. So if you've ever seen when they put those little styrofoam balls in the sound and you see the sound bounce back and forth off of a plate, it's the same concept, but instead of the styrofoam balls, you got your energy going right through that zone. Okay? So that zone locks in there. The next one locks in the next zone. Now that's why it's so hard to adjust this thing what you're going. You have to have the number right when you first start, or else, you know what I mean? That's why it's so important to get the data on it. It is where it's locking at. Those two lock. Mechanical doesn't lock. Now, what the mechanical does do is it has to be at a low hertz. This is what people miss. You need to try to make it slow, not extremely fast, because you need a low beat rate. And you'll see the beat rate in the camera. And you notice that it zooms in, it zooms out, it zooms in, it zooms out. I'm not screwing with the camera itself. It's the beat rate in the room messing with it. It's as that bubble goes like this, then my camera zooms in and out, right? So it goes boom, whoop, you know, and boom, whoop. And the only reason there was no computer in the background and stuff, and I could tell you, I know I didn't put any sound on it, so you wouldn't know. But my computer never went off. Okay, not in the successful test. In the ones that weren't successful, well, let's just put it this way: it takes out your room. So you got to understand you got a beat rate going on there, but that has to be in the low hertz. When we first started testing, it was in about the 20 hertz scale. Somebody got back to me on the sound on the camera, and I had a microphone that would pick it up, and it gave me the 20 hertz. We're looking at that was the beat frequency why the Tesla coil was putting out kilohertz, right? And it was so far scaled off. My kilohertz when I first started with my small coil were right around 700 kilohertz in that range. I brought that down to about 250 kilohertz is what I run now in my basic coil, the one Joe and I both own. And what it does is it takes the hertz level down even further. What you're trying to get, I don't want to say this, it's kind of like the RAV in the center, how it looks like it's doing nothing, but it's doing everything. And it's because it's getting into a time dilation. That's what you're trying to achieve here. Without the dilation, you're trying to achieve the low hertz level. So you need that low beat frequency going on in between the two discs, and it'll build out in harmonic. So the top disc and the lower disc have to be 1/3 of each other. So the top disc has to be 3 times faster than the lower disc in order to get the binaural beat frequency, or else you won't get it. Because when you see it on the oscilloscope, it's like this. You have that horseshoe. The other horseshoe has to come under it, but it has to come, a distance off of it like this, right? If it's misaligned, there's no beat frequency. If they align, it amplifies. So you get a binaural beat, which makes the outside go like this, which is what you want. You can't have it sitting just as an outside field like this. It doesn't even work. Even the earth doesn't work like that. The earth works in that beat, right? And that's exactly what you're looking for when you guys do this.
Well, you start to have that effect that you can even see when you look very closely at your videos. And I'm certain that if you were to see the raw footage, not the YouTube footage or if you'd sent it through Messenger, you'd have a much better, clear visual of the fact that there probably is some mild, albeit present, time dilation occurring. Because you start to get that pseudo strobe light effect on the image, which, like, if you've ever seen anything vibrate extremely, extremely fast and it looks like it's here and there at the same time, it's like that, except one major difference is it affects the surrounding environment as well. Okay, like you could see the visual like Sahara heat sort of deal, but it's different in a way because it's not like waves going up or something like that. It's just sort of abrupt variations of the surrounding environment, in in a very specific and continuous direction. That's not necessarily just rising. So That's present in the video. I saw it. I was going to edit together some more stuff, but I really, I really only had 10 minutes to even throw together the piece of poopy that I did, just to show the fact that, like, it's not easy to see. Okay, if you just watch the video, it's great. It doesn't have discernible lift, but when you zoom in, even at full speed, you don't need to slow it down or speed it up or anything. You could actually see the lift, and I wanted to make sure that people were able to observe that, because this is not just some kind of fluke thing where it's
Oh
screwing with
God,
the
no.
needle. Yeah, it's not screwing with the needle or something. Something went up and stayed up, and that says something, right? So it's important to realize that.
Now, I just want to point out, and Joe will probably know the name right offhand, the gentleman who does the electrostatics. He's known for like the lowest number on anti-gravity. I think he's getting millinewtons or something, and he calls it thrust in a vacuum chamber. I just want to point out, guys, this experiment is completely different than that, and they should not be judged in any way equally or anything like that. Electrostatics is a completely different concept than what's going on here.
Yep.
The fact that they put it in the vacuum chamber negates any kind of correlation, you know what I mean, between the two. That means the amount of weight would change completely. Mine is based on the environmental condition of the Earth. Okay, that's what we're dealing with only. I'm not trying to go to space with it. It's not going to be working in space, so I don't need to put it in a vacuum chamber. It's just simply the air, the environment in the air, and the fact that I know that we're in a gas field and I know how to structure it. Okay, that's basically what we're dealing with here. So I just want to put that out there. I don't want anybody to compare them or anything like that, because it's not what this is.
Yeah.
If we were dealing with electrostatics, man, I could give that guy a handful of devices. I worked in electrostatics for a while. I mean, I don't even think that they're at the point where they take a non-conductor and make it a semiconductor in their experiment in order to generate more force. I mean, let me put this way as simple as I can. You can go over to scale right now. Go get you a digital scale. Take you a copper plate about this big. Go take you a couple napkins. You know what I mean? Some regular bathroom napkins that they have at the outhouse. They're kind of bigger. And then those very small ones, about the size of a dime, put it on top of it. Put a positive and negative on it. And as soon as you hit that button for them to go, boom, it'll create a force. Every time it'll create a force. So a force on a scale is nothing. That's easy, okay? It's taking and accumulating mass into that force. So you would have to take a geometrical object in there in paper that has not a lot of mass to it, but as soon as you put the energy on it, the field that grows around it would create a lot more mass and give you a lot more force down, okay? That's taking a non-conductor, which is paper, putting a field charge on it, making it a semiconductor, and then creating a heavier force in one direction. It works because the papers mesh. And I believe people like Ling Li, I think her name was, or the Asian lady who did anti-gravity, they know that. Okay, it should be well known by now in physics that you could do that. And if they're not doing that, then they're missing out on a ton of force they should have. The only problem is the last time I watched some of their stuff, their chamber itself bends metal, which means they have way too much pressure going on, which would crush any experiment you want to run in it. So, and I don't think space has that much force. So the tin cans they put up there for people to ride in wouldn't be so thin. So, I mean, let's put it this way. They were using basically gold foil on a spacecraft that landed on the moon. That doesn't have that much pressure in it. Okay. So let's just be honest. That's kind of wrong to do. I'll leave that aside, man. I just wanted to make sure I made that clear. That it's not the same thing. It shouldn't be viewed in the same way. And I respect what they do, and hopefully they do really well at it. I just know electrostatics for me is not the answer. I've already went down that road. The reason why this is special is because it does work in the environment. It's teaching you about the environment. It's showing, hey, what you think is a magnetic field in an environment is a faint magnetic field with a higher amount of cold fusion radiation is what you have. And that's more prevalent here. And it turns into a hot fusion reaction as soon as the sun amplifies the power in the earth. You basically get hot fusion and you get burnt, you know what I mean, by the radiation in the atmosphere. So That's how you know the difference. So all you're doing is you're coupling in that field, and then you know that there's gas around it. The reason why I found this field is we're sitting there watching the 6 foot Tesla coil, right? And my buddy started it up, and he's got this exercise ball on it, and he has a tinfoil sitting over the top of it. And as soon as he started it up, just understand where that ball is. It's partially in the center of the coil. It's out as a top load on it, and it's taking gas and pressurize it inside of a ball. Now understand the tinfoil aspect of it. It now makes the center of it try to build out into a size here, and then a size and a size, and that has to do with just the amount of density goes to the center. It self-organizes in the center. On the outside, it puts out a field in the environment that takes the actual air molecules and bends them around it.
Yep.
Then, when it wants a spark, it makes a tube that goes off like this, and then inside that tube, it sparks. And the spark doesn't come out of it until there's a tube built. So you knew that there was a way to take the field of the Earth itself and pressurize it around there. It was in that radiation. For those who think Tesla coils put off static electricity, they don't. They put off radiation. And why is that? Because anytime you take high voltage and compress it, it creates radiation, not static electricity. And you can see that in each winding. And each winding, you're building the radiation as you go. People get sick and die from the radiation from a Tesla coil. Trust me, it happens. And that's the difference. Static electricity wouldn't do that to you. It'd shock you. When you go and put the wire down this, it's hot. And you could have it on the coldest metal surface, and you're still burning your finger. The only thing that does that in nature is radiation. And as soon as you know that, you should really rethink the way you do it, because some great people out there who do Tesla coils still think it's static electricity because of the way it shows up on your oscilloscope. I'm sorry, it's not. You're dealing with a radiation field. Once you know that, then this kind of project can work. If you don't know that, you'll be lost.
It's hyper nuanced what you're saying right now, because I mean,
it matters because
it does matter, but it is hyper nuanced though, because the reality of it is, as it builds out, when it lacks vector, it ends up being a static potential. But then there's something that kicks it into a state of excitation. As soon as that excitation occurs, then all of a sudden it's vector and it shoots out. And then
hold on. It's not electrostatic and potential at all when it builds up. Period.
Okay.
Well, okay. If it did, then you'd walk by and get shocked by the energy and as a volume in the air, and you don't get any of that. If it touches the surface,
not when there's field compression though. When it's field compression, that's allowing for the accumulation.
But here's why it's so nuanced and why you have to understand it. If you're in electrostatics, you would get the misunderstanding that a Tesla coil is going to give you the correct energy in electrostatics to make your field work. Okay? That's an impossibility because it can't. It's in radiation, not electrostatics. Okay? So it's a complete failure in that part. That's why it has to be nuanced. When you're dealing with the environment, electrostatics won't build out that way. They've been trying that 3M experiment forever, and they can't get it right because it has nothing to do with the electrostatics of the 3M product. It had everything to do with the hot and cold going on in the fields inside of that warehouse.
Right, but now here comes in the reason that there's a weight reduction here as opposed to full-on lift, right? Because at this point, once you start to get a weight reduction, now it comes down to multipliers, okay? Because you need something to, multiply the effect, densen the effect in order to get the full effect, right? And this is why it's not a total break of locality, right? So we talk about locality breaks all the time, what it would mean to break the locality, meaning it basically create a cavitation bubble, push out the environment entirely, and have the environment suck in and deflect off of the fields and the field bubbles that are created. Now, in this particular case, why you see reduction is because you're dealing with a conditioned environment, okay? A conditioned environment. right? Like Nathan was saying before about how the Slayer works, okay, to put the entire area into resonance. The fields and the magnetic fields building out, and they build out on layers as they reach certain density levels, and then they don't pop, but like there ends up being sort of like a scalar type reaction where there's a collapse event that actually does push it out, and then it starts to accumulate out from there again, reaching a different layer of saturation. The thing that's lacking in order for locality to be broken is compression. Okay, because once you have compression of the outer fields, and there's less of a gradient, okay, then there becomes the attractive force of the outer of the unconditioned environment to bring it in, right? Then it becomes conditioned, but as it reaches into higher density levels, which is almost immediately because again it's compressed, right? Very small diffusion zone. Well, if it comes in, then it gets repelled away, and that's sort of the one difference between broken locality, not broken locality, a conditioned arena versus a actual functioning habitation event. Because realistically, if you want to talk about, and again, we say anti-gravity, but at the end of the day, it's not really anti-anything, right? It's just changing the entire relationship of the matter in the environment.
Yeah.
And it's important to realize that. I mean, whether they've proven this or not, the fact is that based on what everything we know and they know, they being accepted science and physics, right? The, uh, Gravity is a relationship of matter and matter, and it has to do also, as I've said many times, to do with an energy exchange that occurs, which is why the relationships, et cetera, why mass makes a difference, as far as or density. Realistically, it's density and volume, which we see as mass, right? But mass only matters if there's gravity. So, but if you look at the relationship of volume and density, right? And then as the matter starts to couple up together, it's that relationship of matter that defines what the gravity is going to be anyway, which is then directly related to an energy exchange that's occurring. So,
Yeah.
take it as you may. Once you break the relationship between the matter that you're affecting inside your bubble and the matter outside of the bubble, and they no longer have the same relationship, well, gravity no longer affects it the same. So,
Yeah.
well, there you go. But it's not anti anything because gravity still exists, and it still exists in relationship of your craft, right?
Yeah. No,
Right.
it does.
If you're on that craft and you have something in your hand and you drop it, well, you have a center of gravity in that craft, and that would be affected. Like it's not. I don't believe it to be zero G's, so to speak, right?
Well, see, here's the thing, and I'll just say this to you: if the high voltage structures the air before it moves, it lends to the fact that it's going through a pathway with little resistance in it, or no resistance. It could be. So I'll hold out hope that it could be, you know what I mean, in that way, just because of that reason.
Well, but now if you think about it, right? So if you think about a broken locality in the first place, right? It's traveling in an environment in which it's not connected to, right? Is it traveling at all as far as it's concerned? And the
It's
answer
like a
is no.
wormhole. It's like it's
The
just
answer,
going.
right. The answer is no. Okay, because as far as it's concerned, it hasn't moved relative to anything else inside of the bubble, and that's all it knows at that
No,
point.
I'm not saying you wouldn't have
Right.
gravity. I'm
That's
saying
why you
that
don't feel the inertial
inertia
force.
wouldn't.
That's why you
Inertia
don't
wouldn't
feel the
be.
inertial force of the acceleration, deceleration, of it. Because relative to what the bubble, nothing has moved or changed.
Yeah.
You're
Yeah.
moving the environment, moving the environment around.
Just like I'm saying, there may not be an inertia force, but there's still gravitation inside the craft. But this craft would be horrifying, by the way, for anybody to be in it. It would just not be fun. You would end up very badly. You'd have to reconstruct the whole thing to put any passenger in this type of thing, This is purely just a scientific thing to prove it. Um, so how do I say this? In this thing, we have other tests, okay? And I haven't shown them yet. Just understand that it's going to lose more weight.
Yeah,
If I come out,
we already know that. Just so people.
some people don't, man. Some people think, "Oh my God, you hit a limit." Nobody else has broken that number yet. The craft originally is anti-gravity, as far as people know. I know Joe and I both don't believe in the word anti-gravity, but we'll say it because it's an understandable term and what we're talking about. So just understand there's more to come. And we have gotten it quite a bit further. And I'll leave out the last part only because once you cross a certain line, the government shows up at your door. And I don't want that. I want all the information out there. And that's why I'm pushing so hard to put in that mirror, to put in, all the testing equipment. So it's all out there before anything else happens. Okay? Just understand what I'm trying to say. That scale has no problem reducing more weight. Okay, just understand we didn't tune it. This is something that was set back to an original spec on the measurements. I basically take my tape measure and measure exactly where it was. It's written down in a book. This is what worked at this time. We now go to it again. We put it back in there and do it again. That's why I use the old Graviflyer, not the new one that I have sitting over here. That's why, you know what I mean? The harmonics are not exactly where I want them at. The fields aren't exactly where I want them at. And that's why it's still a wobbly POS and everything else. But it is functionable to show you guys this until we get to that next stage when everybody's okay with it. So, yeah, this thing, there's a lot more out there, but I'll say this. When you start to understand this a little bit better, you start to understand why. Joe, I ran a number calculation on something, and I just want to throw it by you. When you put this thing at the top disc going about 4,700 RPM, your high voltage field normally comes out right around, oh God, what was it? It was like 53 kilohertz or something like that, okay? And then the Tesla coil would come out about 220. That's in a 369 thing. The first number multiplied by 3, the next one multiplied by 6, the next one multiplied by 9.
Yep.
It's funny how the configuration works.
Breaking out in thirds. See, that's one way to think about it is as a multiplicative. But at the end of the day, once you realize that it's sum of the whole, you end up with thirds that it's breaking down into.
Yeah, it's a harmonic, right? It's a third harmonic, right? Yeah. So I just thought it was funny. I thought I'd throw that out there because I was looking at some of the stuff again and just kind of crunching the numbers and see where it landed. Well, and it's ironic that
we all know based on the math that I've shown and just how it plays out.
Well, I think I was looking at it.
If you need to take that 9 sum, then and you need to just finish and repeat that pattern till it builds out the 10 count. That third 10 count. Because once you get that third 10 count, that's exactly what the missing component is. Because that third 10 count is the compression. That's the one that wraps around the both of them, right? The both of the fields and pulses and squeezes.
Mm-hmm.
That takes it from 9 to 10, and it changes the average, right? We've said that a bunch of times. And what happens when you change the average? It's that all the numbers they fall into a different relationship. And that's what's key, because it's all fractal relationships of how these things build out. So if it's building out that way, it's building out in the right proportions, right? So now it's just a matter of getting that peak frequency to fire correctly, because you got to remember that 3 and 6 firing in exactly that repeating sequence, to light up the 9 at the top of the little spiral math thing, getting that to hit at the right sequence is critical, because they hit in such a way that the timing is the collision at the central point. Okay. And if that timing is at a little off, then it's a miss.
Well, it's because the waves don't cancel. They put out a beat frequency, which is an amplification of the power. That's
So,
exactly why
so
it has to fall in line.
if it's off in the sequence, even ever so slightly, then you don't have the third piece of that compression event. And the crazy thing is that let's say you incidentally got it, like, but then it fell out again, right? You would actually see a significant reaction right at that point. If you
So
just
let me just explain this to people. Okay, so say we have these discs, right? And we got like several of them, and there's a little light at the top of each disc. Okay, and every time you get to the right frequency, it lights up. The next one lights up, and the next one lights up, and the next one. Right? This is what we're talking about here. So every time one lights up, you got a multiplier of one. Now the next one lights up, and you got a multiplier on that multiplier of one. So now you double, right? Now we're going to triple it. Now we're going to quadruple it. Okay. And what we're going to end up with a cascading energy that's going to go through the entire thing and do a massive multiplication on this. So when you want to ask where's the energy in the craft, it comes out of the beat frequency in order to align them properly to get that massive spike in energy. So as each one lights, boom, that's just your multiplication level going up. That's the amount of energy increase you're going to get. And it only happens when they align. And like I said, on your oscilloscope, it'll show up as a little hump, and then another one under it, and then another one under it, and then another one under it, another one under it. And when they hit all in line, boom, that's where all your power of your lift's coming from. Is that exact reaction right there? That's where, in my opinion, that power of your lift's coming, because that's exactly what's tied into that piezo, and that's what's giving it the power to just boom, pull it right out of where it is. Okay, so yeah, that's my opinion on it. Ulysses, I just want to say thank you very much, brother. I really do appreciate it, man.
that's awesome.
Rock on, brother.
20 pounds and 925 sterling.
I got to explain this real quick before I forget. Sorry, guys. The center plate, the reason that it's in there is because it's an amplification of the asymmetrical capacitor. It has to do with the volume of energy. So if you saw the craft's energy field, it looks like a football on its side. Okay? Just imagine that. So it goes out from one side, over top the disc, and then back down to the other side. And then it does the same here. So it looks like a football, right? Well, the reason it does that is because that's the total amount of energy that's going on inside the craft. Because the high voltage is so low in amount of energy that the Tesla coil takes over as the turning point for the volume or the increase of energy for the entire thing. So as soon as you increase that Tesla coil, it increases the amount that it comes off the plate. So it'll go right over both those discs. It looks like a football in there. Okay. That's the reason why, because it's building the capacitance inside the field. The high voltage there is to structure that. So it's basically to put a frequency inside of it so that it layers it and locks it. That's what you're doing. So you're having a 3-layer of lock going on. The mechanical locks in on the lower side. Then you have the high voltage. Then you have the Tesla coil. It's a 3-layer lock. But basically, it's holding in the amount of capacitance that's going on in your open air capacitor. That's the only way that it holds it in properly. Without that, it just bursts out, and you basically EMP your room. So just so you guys know, in testing it this week, my computer completely went off. Everything went dark in my entire room. Okay, my lights went off, everything. Okay, I totally just like, boom, hit it, right? Because I'm pushing the button, right? Thinking I have it in the right thing. I'm trying to get on the edge of it. It's kind of like you have an AC Tesla coil and you're right on the edge of resonance, and then you miss, and it's nothing. But this time I over hit it and saturated the field immediately. Then it goes, and I'm like, oh my God. And I thought, how much money did I just lose? Is this first thing that came to my mind, like how much did I just lose right now? Because there's some expensive stuff sitting around here, man. And I got freaked out. But
Well, it's like
That's what,
breaking a dam, so like there's a little bit of a torsion wall that exists, right?
yeah.
So when you amplify it, it starts to push out again. It breaks through that torsion wall, and then all that energy that's escaping, right? But what's interesting about it is it allows for the fractal layer, okay, which ended and started into its collapse again, which then starts the saturation of it, right? So it starts to go to a state of diffusion, reaches a state of diffusion where it it's not pushing out anymore. Now it's sending back in, right? Then starts to get dense. But once you push past that threshold, right, bang, then all of a sudden it starts it again, but from that outer point. So you could keep on pushing it out and out and out. And now if you the thing is that and it takes longer, okay, to saturate those further layers because they're just much larger areas. To ultimately, so therefore the capacitance, right, is higher in those areas. So it takes longer to saturate them again. But then it comes to such a point where you reach the point where when you push it to blow it out again, you're going to pulp everything because I mean, what you're doing is you're expanding the magnetic field, at that point, that's the reality of it at least. But I mean, I've played with different amplification type events with my Tesla coil, except unlike Nathan, where he's like, all right, well, let me pulse it out and do it now. Mine just grew and grew and grew and grew like it didn't know like it wasn't finding a balance, because well, in my method, how I did it was I was taking the energy out of the center, and then transmitting it, okay, separately through a second field on top of the coil itself. But then I was creating a scalar zone. So what was ending up happening was, as it would come back down, it would go into a scalar, but then it would collapse under the two fields that were bouncing off of each other like that, right? So it's just pushing energy out radiantly from this, you know what I mean? And it just like would just continuously expand and expand and expand. And at first, you'd only be able to like get all this radiant energy in between these two bands that I had going on, like you're like pretty close. But then if you let it like run, you couldn't go anywhere near the damn thing, and you'd be standing 6, 7 feet away, and the light would barely light up or light up, at all, whatever, not light up at all. And then you would get into the laser beam line where you would cross over it, and then the thing would just go and light up, with crazy shit. But I'm just saying, there's a lot of different ways to push these fields out and have these energies come out from it. But if you're not building up the right way, then you're not gonna ever get the effect. You need to be able to get the densities. So you get that third vector, and then all of a sudden you can take your diffuse field bubble and then crush it all down, and then that every little tiny bit that you bring it in, the density level skyrockets because it's a lot of surface area, a lot of capacitance, right? That you're reducing the size while the energy is still held in. So it becomes interesting because capacitance is a material property, right? So if you're compressing it, that means that you're also compressing the material as well, the air, the environment, you're compressing that. It's coming along with your compression is the point. So it's not staying where it is. You're just slamming it into a smaller area. Yeah.
So, I wanted to measure this too. It's the RAB puts off, I believe it's DNP, dynamic nuclear. I don't think it's propulsion. It's something else. Anyway, the RAB puts off that field, and it does it better than anyone I've seen out there. And trust me, I've seen a lot of them. It showed you the inside of it, and I'll just say this compared to the Graviflyer. The Graviflyer has mechanical parts on the inside, so it can't reach the same energy level that a RAV could.
Damn right.
So it's set based on the rotation of the two discs, okay, which is still low, still has a nice low beat frequency, But the RAV itself has a different feature because it's all electric on the inside, and it builds out the magnetic this way, and it builds it out in the radiant sheath zones. Okay, what it's actually doing is this the sheath zone pushes out, it's being forced out, but then it pulls back in. That
Mhm.
dynamic is what happens in your atmosphere at all times. Okay, when you build something like this, that's why nuclear explosions bust out and pull back in, just like this. The environmental condition makes it do that. It's like a rubber band effect that goes on inside there.
Mhm.
Anyway, the RAV, what it does is it takes pure electricity and puts it in little balls in the center. And that's the difference. It can go extremely fast in those zones for those. So it puts off a very high megahertz, probably way past megahertz, I'll be honest with you. Um, and then in each one of the fields, though, you know what I mean? If they go out, it gives off what looks like a magnetic signature, but does not feel like magnetics at all. So if you're resituring the Earth, it's the exact same way. We have a magnetic field that doesn't feel like magnetics at all. You can't go out there with a magnet on the outside of our Earth and have it doing anything special out there. You can't do it in the area that we're in. Getting close to the core of the Earth, that'll probably do something. But it's like two fields crossing in the night. Now, I'll say this.
The Earth's field and magnetism, even though it is magnetism, it's not magnetism in the sense that you think of sticking a magnet to a refrigerator or something like that. It's not. See, because it
But
goes
that's what I'm trying to
right,
explain.
right, right. It's in such a diffuse state that it becomes like irrelevant because it's so large in comparison to any of the material within it. The relationship just the proportions are off.
But
It's just not. It doesn't have an effect like that.
but you got to understand this. It's still magnetodielectric in how it's built,
Absolutely.
regardless if it's that way or another way. So I'll say this: Gerard Morin showed this, and it was fascinating. He took aluminum and he built his generator out of aluminum instead of steel. And what it actually would do, Joe, is if you took a halogen lamp, if you used regular electronics, it'd go through every single capacitor, resistor, or diode in the whole thing. The went through the aluminum, went around the entire thing, went right over top of it, and lit up the light bulb. Okay? It did not need any of the electronics whatsoever. Just understand the difference in there. Two things built out of magnets, copper, and then he just changed the metal type, right? So what would it also show? That the magnetics in it were different. So just understand the difference in the two. If you can understand that, that's why you aren't understanding your environment, because it's just in certain metals that it builds out in. And Earth has a ton of metals that it goes through to give you your field. So you're not going to get the same nickel iron you think you're going to get, where what you think is at the core, it's not going to pass very far in the Earth. Remember, it's way too large of a distance. Anyway, I want to save that because if you know it's in magnetodielectric, all you have to do is amplify the magneto field by locking into the same effect. That's how you couple the energy inside that coil, because you're using the energy of the Earth itself and the energy of the Tesla coil coupling together as one field. That's why it's working. It's
Yeah,
because
I've
it
been
taps
a
right
big
into it.
I've been a big see, and Nathan said it before. Rav does what this needs to do, what Graviflyer needs to do. Rav does the best. Um,
It does.
and I always kind of felt that when I put down how I would build a Graviflyer if I was going to do one, like that's why that was directly at the heart and core of the whole entire system. It's because it is the regulating factor of everything, right? It creates the proper energy exchange. It regulates and moderates and modulates, and it does so in resonant harmonics with the rest of everything else that needs to go on. So,
Yeah.
I think that's really probably one of the keys. If you were gonna, think about it from just like okay, trying to make Graviflyer work the way that it goes and showing, hey, look, it does do something. Here, what you saw it lifted, did better results than NASA did, doing the same test the same way, pretty much, right? Well, long and short, if you do away with the actual mechanical elements of it, all of a sudden start to like lose mass off, right? Because you don't have to have all these
Oh
mechanical
yeah.
parts. Then you're able to bring your energy density levels higher, and then you have the thing that has all the things you need by basis of its formation running the show.
Well,
It's just
yeah.
kind of the way. I mean, that's it. When it
I,
has what you need and you put it in the center, pretty
I,
good,
I,
pretty good
I'm
start.
there. I'm there with you, Joe. I'll tell you this: in this experiment, we can rip a lot of stuff off of this now that we know how it works. Now that we know it, dude, there's so much dead weight on this Graviflyer. Once you understand the 3 plate and how it works as an asymmetrical capacitor, if if you didn't need the motors, you know what I mean? Like in the way that they are, they just had to be low hertz. That's why you use fan motors because they're cheap and light. Okay, you can't if you take off those big DC motors everybody uses. There's a couple pounds of junk. Okay, the top scaffolding to this thing, junk. You know what I mean? You don't need any of it. Could you put a piece of plastic going over there from a 3D printer in order to hold all this whole thing up on top and bottom of the motors? Yes.
I mean, you're gonna gain a little bit because of an outer shell, but you're gonna lose more than you gain. Um, I think that's what it comes down to.
Well, if you did an outer shell right, you would be able to amplify the field way beyond everything because you got to remember what you're putting out there. So, Sean and I were talking just recently, Joe, and I think you saw it as well, about making the bismuth itself the RAV. And the reason for that is the amplification effect that the bismuth has in a liquid state.
Well, so all that is, and that's funny because bismuth does have such a low melt point, and in order to have the arcing to create, you'd have the liquid metal, and then you'd have the liquid metal in this. It's an analogy at that point to the mercury, so you could run it like pure MHD, which the RAV runs like pure MHD anyway. The interesting thought process there is that MHD has, like the way that it is described and they like to present it is always in a form of geometric containment, right? Which is how they're able to get their effect. But would a liquid bismuth RAV need containment?
Well, when you shut it off, you want it contained. I don't know that you want it
Well, if you
contained
shut it
anytime
off,
it's running.
that's not what I'm. As it's running though, does it need to be contained? I don't know that it does.
No, I don't think that it does. I say it has to be contained when you turn it off because you don't want any elements getting out of it or turning on. That's why you need a low point melting material, you know what I mean, to get it going. But then it goes back to the hardened state where it
Yeah.
contains the entire thing so it doesn't go
Well,
floating off on you.
well, this is where we could backtrack now 2 years ago when I said, well, I mean, the geometry kind of looks like two turbochargers 69 each. You know, you're right. You need two shells. One here, one there, sort of deal where it twists and pegs back into each other. Because then at that point, it should form a weird situation where you probably get two RAVs counter rotational on one another, but then they would feed in the actual MHD flow of it naturally, and then you'd have just a double you double the field geometry, as far as the interactive field geometry goes, but then your overall field geometry would stay the same. Yeah, that's an interesting thought.
Oh yeah, I was honestly tempted, Joe. I'll be honest with you. I set up the new RAV for testing, and the whole time I was doing it, excuse me, the new RAV, the new Graviflyer, is I literally wanted to fix it now. If you know what I mean, knowing what
I
I
do.
know,
I
I,
got you.
I needed it for field testing, but I go, well, I kind of paid for everything. I kind of just want to fix it. You know what I mean? So then I go, okay, I think I can make this work. So I found a different thing. I wanted aluminum. I wanted it big, and I want to make the Tesla coil inside of it. You know what I mean? Along with the rest of the components. Okay. Because we're not ready for the RAV yet. We have a lot more testing to do to make sure that field comes out right. You know what I mean? Because it's so self-contained that messing with the environment inside of it is not that easy. I don't know if I could explain that properly, because with the Graviflyer, we're coupling with the field of the environment. The RAV contains everything inside of it. You know what I mean? We'll have to work that out first. So I said, okay, I'm going to take the top of a heater for your backyard. You know, those little gas ones you pull out and you go,
Mm-hmm.
you know what I mean? 33 inches wide is what they are. And the top pulls right out. It unbolts and comes right out, exactly where I want it. I have a whole outside shell, a bigger, just about this distance here is all the inner's going to be, but this long. Now I have the ability to fill this thing in the exact way I want it. You know what I mean? Like
Mm-hmm.
flat out, have it in aluminum already. It already can put a field on the outside. So now if I build my fields properly, I can just simply put them into it and test it. Before I do anything else, I could test it, put it on there, look at the machines around it, and see if the testing came out right. Did it give me what I wanted on the outside? What did it do on the inside? Do I need to put some kind of other material on the inside? You know what I mean?
Mm-hmm.
So it gives me what I wanted to, and then it also gives me the ability to nano coat the outside. Is what I wanted to do. So anyway, I just thought that was pretty interesting. I thought I'd throw that out there. That's where I wanted to go, but I had to do certain things to build for the testing we need to get done, because you know what I mean. Richard out there's building all that stuff for us, and I want to make sure I test it properly for him in each stage that I have of a Graviflyer, so that gives him the full. You know what I mean?
Yeah,
It's
I
the
get
full
it.
write up on everything. So,
Absolutely.
but we have a couple options to go forward with it. I'll say this, and since we're doing the show on the Graviflyer and all this other stuff, when we go to lose weight, I'm gonna try on the next one. We did 1.5 pounds this time. I'm gonna try to double it. I understand that I don't think that Graviflyer weighs any more than 4 pounds. What was it? 6 pounds on the scale, Joe, and then it was 1.75 pounds. I think it was with the plate. It was a wood plate by itself.
I think that's what you're saying. Yeah.
Yeah, so two. So I just rounded up. We'll say 2 to 6. So that's 4 pounds. So about 4.25 is what the thing weighs on the poundage. So if we can get that thing, you know what I mean, to double to 3 pounds, that means that we got one more thing to go after that. And I think we'll hit 3 fairly easy by tuning this thing up before I even get to the next Graviflyer.
Mm-hmm. Yeah. I mean, it's pretty awesome. The amount of loss that you've been saying is, I mean, that's undisputable. It's undisputable. It's
I do
the most similar thing that I've ever seen to this was the Scottish guy that was playing with the gyroscopes. And I looked at his work and I was like, this guy was very, very intelligent. He was playing with it for years. He knew what he was doing. So I kind of always feel like weird and a little awkward if I like notice something. I'm like, if you just made these couple of changes, this thing would have worked so much better. But what it was he had a center rod and it was totally mechanical. It's a center rod, and then
Hmm?
he had two flywheels on a bearing on a pivoting arm. Okay, so there's a central hub, pivoting arm, flywheels at the end. Okay, and what he would do is he would rip the lines on the flywheels opposite directions. Okay, and the thing would start to do this, and then it would rise to the arms up, and then it would start to kind of pull up on the center hub a little. Okay. And then, I mean, realistically, very good result, right? But you have to understand what's going on there. Well, what's going on there is it's creating a new center of gravity. So you know that when you spin something that weighs a lot, right? Like you've all seen some guy spin a plate or a weight rather, right? And then if you start to pitch it like this, it might find stability at certain degrees based on its angular momentum, right? So, you know, what I realized is that if he didn't have the counter rotating fly with the flywheel just opposite each other, okay, if he would have had a counter rotating flywheel on each of those arms and then added a third on the other side, okay, that thing would have went up absolutely positively.
What was his
Because
name? Kid?
I forget his name.
KIDD?
I know he's Scottish, and I know that they were following his work for some time, like academically. He worked for a couple different universities on this testing and stuff. Then they shut his ass down. Then he was just
What?
doing it at home, and the BBC was kind of like checking in on him, and then he stopped doing it. But
Yeah, I remember. What's his name? Lufwady Lof. I don't know his name. The British guy. I know what you're talking about at the British University. The one that does all the anti gravity, and he also talks about the anti gravity. Excuse me, not anti gravity. The maglev train, and he does a lot of that stuff. He knows the anti gravity man. And then, yeah, the guy he was interviewing was the name Kid, same one you're talking about, who had that device. And I saw it, the center one,
so right.
and it.
So the reason that I'm saying what I'm saying though is because if you put the counter rotation on the same axial plane, okay, that automatically redefines the center of gravity, not between the 2 points here and there exclusively, but also independently here. Okay. Now, once you bring that second one in, now they have the relationship to two. Now, if you only have them side by side, like he ever had them, okay, you start to run into a problem with losses because now it's an efficiency equation because you have the relationship between these two things and they're both pulling up and they're doing this, right? Well, if you're trying to move a round thing around a central hub, okay, and one's moving up and down, well, it's contacting that point, even if it's infinitesimally small at each time, and that disrupts then the relationship because of the dampening effect. Okay, so there you need to be able to eliminate that. Now, by putting them off equally at a third, okay, you have this cyclical wobble. So it turns from a plane like this back and forth where it's impacting, okay, to an elliptical. And something that's elliptical is going to be able to sway itself around object, the central hub, do away with those losses and be able to rise. He never got to that point in his, you know,
Mm-hmm.
thinking about it to realize such a thing, I suppose. How these brilliant people don't come up with this shit, I don't really know. Why I come up with this shit and they didn't, I don't really know. But this is the way the world was made, I guess.
Well, I think part of it is you got to protect yourself when you go into a university. And I don't mean that they're going to steal everything. I mean it the way you work.
Yeah.
He was going out to his garage every day working on this thing after work and everything, right?
Yeah.
But then when he's brought to a university, he's out there trying to explain it to somebody who has no idea what the hell he's talking about, right? And he's trying to get him into the groove of doing it instead of progressing in his work. You know what I mean? That's what I'm saying. No negative connotation towards anybody in teaching. It's just simply how you work every day. You come into work, you do your thing, and you learn things and you advance things. When you go to show somebody, you have to slow down. You have to take them by the hand, and then let's just be honest with you, man. Not everybody's going to
But
get it.
the stuff is, I mean, for what it's worth, though, it meant like what I was saying about there being three and then two and two, whatever. But this, it's all in the numbers, and it all has to do with the same stuff. And I want to make the connection for people here, okay? Because
Mm-hmm.
the same reason that I just explained mechanically why. you're dealing with a tilt, 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 tilt versus an ellipse, right? Well, there's also a numbers game going on here, right? Whenever you're dealing with two of something, you're working in tens. Okay. When you're dealing with three of something, you're working in thirds. Okay. And if you also have two spinning parts on each, you're also working in tenths. Okay. So you're working in the threes to get the balance. Then you're working on that to bring it up to get that other that other axial element to
Yeah.
allow for that lift to occur. And when you're looking at the Rodin spiral thing, that's exactly why the 3 and 6 ignites the 9, because right, 3 is thirds, 6 is thirds, but it's also of a second, and anything of a second is also of a tenth. Okay, so and that's what the correlating factor is. That's why the average changes, because the 6 is divisible both by 3 and 2. I know it's like it sounds like crazy man talking nonsense and shit, but if you've been picking up what I've been putting down for a long time now, it's I'm sure it makes sense.
Yeah. Well, I'm there with you, Joe. Try to explain to somebody who has no idea what you're talking about how you couple the field of the earth. It's like talking to AI. It's completely worthless. Okay. That's why, I'll be honest with you, that's why I put no sound on this. I could have told you all this information on that video, right? But I got to the point in it where the only thing I get is some jerk off a hole that turns around and says, I'll believe it when I see it. Or all talk and no show. And you know what I mean? It just gets old. And then I get that one, the guy, oh, the bane of my existence, Mr. Strings. Okay. Yeah. I just, dude, that's why I stopped showing it a long time ago. I just got frustrated. It's like, dude, I'm doing good work. I didn't originally make this device. You know what I mean? I'm reverse engineering it based on everything that we got. And you know what I mean? So I'm not responsible for whatever the hell he did. Okay. And I don't really give a crap. The whole thing was is can you make it work? And I'll be honest with you, man. At this point, when you see it, yeah, it's starting to show that it's starting to work. No matter how crappy you think it is, no matter what you think about it, no matter how much you looked at it and dismissed it as a so-called scientist, then guess what? You shit out of luck when it comes to the answer now because I talked enough. Now I'm just going to show it. And I don't know that I want to put volumes in this stuff anymore. I just want you to understand that it does it. And then past that, I've said enough. You know what I mean?
Right, right. Well, I mean, sometimes you just got to let the work speak for itself. And the people are going to either follow it and choose to go with what they followed, what they see, or they're just going to look at it and be like, no, another nothing burger from whatever because it didn't come out of whatever lab. I mean,
Yeah.
I hear this shit that comes out of CERN all the time and stuff, and they preach it like it's like some wonderful new thing, and then less than 6 months later, they're like, "Yeah, that wasn't the case," you know, and it's like, but give that all the credence in the world because they're smashing shit together. Whatever.
I love it. Put the comments on toilet paper and sell it.
Yeah, that's it.
Yeah, no, I think I'm just gonna put it out this way, dude. You know what, Joe? We can always go back and talk about it.
Yeah, listen, write the formula to the universe on your leg while you're taking a shit, and then take a picture of it, like with like your pee in like the corner of the photo, and then just like put it for sale, and like call it art.
Oh man, if you put their prints on toilet paper, man, you might have a permanent tattoo on your ass from it. Yeah, no, thank you. That would be funny though.
Oh, good. While we're off topic, I did go mining again last weekend. I was trying to hold off on mentioning this for a while because I was hoping Deadfish would be here. So I wanted to show
Okay.
you. Oh,
Oh yeah, Joe, famous Joe. We saw his picture on Facebook, man.
yeah. Oh yeah, look at this one. I got another one. I got another huge one. It's a diamond.